Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. NaHSO3, sodium bisulphite, undergoes nucleophilic addition to carbonyl compounds. However, this reaction is subject to steric limitations. The bisulphite ion, HSO3, is a relatively bulky nucleophile. The reaction proceeds readily with 1. All aldehydes, unhindered carbonyl with at least one H. 2. Methyl ketones, CH3, Co-R, where one group is methyl. 3. Cyclic ketones with 8 or fewer carbons. It does not react with ketones where both groups on the carbonyl carbon are larger than methyl, i.e., ketones with 2 alkyl groups each containing 2 or more carbons, due to excessive steric hindrance. Now evaluating each option. A. CH3ChO, acetaldehyde. This is an aldehyde. Aldehydes readily react with NaHSO3. Reacts. B. CH3, Co-Et, butanone methyl ethyl ketone. This is a methyl ketone, one side is CH3. Methyl ketones react with NaHSO3. Reacts. C. Et-Co-Et, diethyl ketone pentane, 3-1. Both groups attached to the carbonyl are ethyl groups, each has 2 carbons. This creates sufficient steric bulk on both sides that the bulky HSO3 nucleophile cannot attack the carbonyl carbon effectively. Does not react. D. PHCH2, Co-CH3. Phenylestone one group is CH3, methyl, so it qualifies as a methyl ketone. Despite the PHCH2 group on the other side, since one substituent is methyl, NaHSO3 can react with it. Reacts. Therefore, diethyl ketone, Et-Co-Et, option C, does not react with NaHSO3 because both alkyl groups are ethyl, making the carbonyl to sterically hindered for the bulky bisulphite nucleophile. Therefore, the correct answer is C. Therefore, the correct answer is option C.